Okay, last thing I'm going to do is go ahead and work through all of these problems. I will post these on It's Learning as well. We are in quadrant 2, and it's nice to have something to write with. Quadrant 2, so I need to draw this in quadrant 2. The angle's doing something like this. The sine is 1/3. 1 squared plus b squared equals 3 squared. Guys, the mood I'm in, whatever, may cause me to switch sides with c, but that will not matter as long as a and b are together. So this is going to be 9 minus 1, so b is the square root of 8. Now 8 just happens to break down negative root 8 to, if you don't know this, it's 2 times 4, and I can take the square root of 4. I cannot take the square root of 2, so the square root of 4 comes out as 2 times the root of 2, all right? And usually it's best to have these rationalized before I start. So there's my numbers. So sine of 2 theta is 2 times sine theta cosine theta. So that's going to give me 2 times. My sine is going to be 1/3. My cosine is going to be negative 2 root 2 over 3. All right, so I need to make this into a whole number. I mean a fraction, just kidding. So 2 times 1 is 2 times negative 2 is negative 4 times the root of 2 over 3 times 3, which is 9, and I'm done. Going on to B, I'm going to use cosine squared theta minus sine squared theta. And cosine squared theta is, wow, believe it or not, if I'm going to square it, the square root of 8 squared is faster to do than 2 root 2 squared. So I'm going to back up and back pedal. I feel like I'm back paddling. Backstroking? I don't know what I'm doing. Over 3 squared minus 1/3 squared. If you will look at this, you will understand why I left it as the square root of 8 instead of 2 root 2. When I square the square root of 8, it just becomes 8, and this is over 9. 3 squared is 9. This applies to both pieces, okay? So the next one is minus 1/9, which is a total of 7/9. Now, I don't know about you, but I prefer squaring a perfect square as opposed to 2 times the root of 2 squared. All right, last one, tangent of 2 theta. This one's the tougher one. It is, I believe, 1 minus, I got to go back up and see, sorry. Oh, it's 2 times tangent, not 1 minus. All right, 2 times tangent. I'm going to have this memorized, or I'm using it again. I forget this one every year. 2 times tangent theta over 1 minus tangent squared theta. So 2 times tangent. This time I'm going to use this one broken down. So it's 2 times negative 2 root, hello, that was in the denominator. My brain just totally went south. Sorry, let's fix this. Tangent's 1 over negative 2 root 2, all right, over 1 minus, now I'm squaring it, so I'm going to use the square root of negative 8. 1 over the root of negative 8 squared. Now look how I used both of these in the same one. Let's see if this makes sense to you. In this one, this goes over 1. My 2's will reduce, and it does leave me negative 1 over the root of 2. That's the numerator. I'm going to color code these. The denominator will leave me 1 minus 1 over 8. Okay? 1 minus 1/8 because I'm squaring the top, Squaring the bottom, the negative got squared, it's gone, but this negative holds its place. Now, this 8, this 1 does not have a common denominator, so I'm going to make it 8 over 8. So it's going to be divided by 7 over 8, 7/8. All right, I'm going to keep change flip times 8 over 7. This is gone. This leaves me negative 8 over 7 root 2. Now, that 7 root 2, the root of 2, cannot be left into the denominator. The 7 can, so I'm just going to multiply by root 2 over root 2. And this final answer is, sorry, this was left in from the work I did above. It's going to give me negative 8 root 2 over 7 times 2. Now, I didn't combine these because I know 2 will go into 8 4 times. Negative 4 root 2 over 7. Final answer. Not as clean as the tangent on the half angles. All right, so doing the next one. And you could have taken that shortcut. On this next one, I'm going to take the shortcut because I am finding sine, I am finding cosine. So finding tangent is actually a little easier than setting up this problem. All right, so this one is going to be 2 sine theta cosine theta. We will prove this in the next unit, just not yet. So, it would be nice to notice that I'm working in quadrant 3. So over here, quadrant 3, and notice, remember these two numbers have to be negative. Sine is 12 over 13, and this is a 5, 12, 13. It's Pythagorean triple. So I know the 5, or you can do Pythagorean theorem and figure it out. All right, it is negative because of the direction. So I'm going to get 2 times sine theta. Sine is negative 12 over 13. Cosine is negative 5 over 13. These go to positive because 2 negatives make a positive. And I'm going to multiply these out of order. 2 times 5 is 10. And 10 times anything just adds a 0 on the back end. 120. 13 times 13 is 169. I'm finished. All right, let's go to the next one. Cosine squared minus sine squared is what I'm filling in. So cosine squared is 5 over 13 squared. And yes, it was a negative, but when you square it, it's going to go away anyway. Sine squared is 12 over 13 squared. So that's going to give me a total of 25 minus 144 over 169. Now, I will tell you, I don't know what this is in my head. So I'm going to come up here and go 144 minus 25, 9 would be 2. It's now a 1, 119. Okay, so this is going to give me, and I don't believe 119 will break down. I'm 90% sure of that. All right, so this final answer is 119 over 169. All right, done. All right, so I have these two answers in yellow and green. So I can take sine over cosine. Sine of 2 theta over cosine of 2 theta. I know them, so why not? That's going to give me 120 over 169. That's the sine. And the cosine, I'll color code it. This one, I'm going to put it over 119 over 169. Those of you that like to cancel denominators, whoosh, whoosh, it's gone. If you like to keep change flip, you can do that as well. I'm at 120 over 119, the end. Look how fast it is. If you already happen to know sine and cosine. Okay, let's see what else I can do real quick. Half angle, these are from Tuesday's work. So I'm in the first quadrant, quadrant 1. I have tangent is 3 over 4. This one is a 3, 4, 5 because 5 has to be the hypotenuse. You only have a 3, 4, 5 when the hypotenuse is 5. So given that I have my theta, I have to do, it's going to be a positive because if I take half of a first degree, something between 0 and 90 degrees, it's going to be between 0 and 45 degrees. So this is going to be positive square root 1 minus cosine of theta all over 2. So filling this in, 1 minus cosine is going to be 4/5 over 2. This has to become 5/5, which is going to give me 1/5 divided by 2. We're going to put it over 1 so we can keep change flip. This is going to give me the square root. This is now gone. This is going to give me the square root of 1/10, which is the square root of 1 over the square root of 10. Guys, you should be able to do this. That's 1 over the root of 10, and you can't leave it like this. So it's root 10 over 10. It's technically 1 times that, but 1 times anything is itself. This one is going to look just like this, except it's 1 plus cosine theta over 2. So if I have 1 plus cosine theta over 2, I'm going to end up with the square root of 1 plus 4/5 over 2, and this becomes 5 over 5. So I'm down with 9 over 5. Put it over 1 times 1/2. That's going to give me 9/10. And then that gives me the square root of 9 on top, square root of 10 on the bottom. 3 over the root of 10. Can't leave it like that. 3 root 10 over 10 for the same reason the last one was. This one is, oh my gosh, total brain fart. What is the tangent one? I don't have it in front of me. It is 1 minus cosine. I'm going from memory. I hope I'm right, guys. 1 minus cosine theta over sine theta. Okay, so 1 minus cosine, 4/5, divided by sine, which is 3/5. So the one thing I have to do here is multiply that, or change this to 5/5. So now I've got 1/5 over 3/5. Okay, the last one I canceled out the 5s. So this one I'm going to keep change flip this bottom number. So it's going to be 5 over 3. The 5s canceled. It leaves me 1/3 and I am done. Okay. This one I'm doing the theta over 2. So this I've got to pay attention where I'm at. First quadrant. First quadrant's here. Here I've got 12 over 13. This side is 5. This is my theta. All right, so sine is equal to the square root of 1 minus cosine theta over 2. My cosine is going to be 5/13. The square root of 1 minus 5/13 over, and there's no negatives in there that weren't there to begin with. Make this 5 over 5. This becomes, oh, it's not 5 over 5. Duh. Sorry, it's 13. Wow, did I get rid of way too much? Lost my big square root, and this should be 13 over 13. Try that again. 13 over 13. I was like, yikes, I can't get 0. That's not right. 13 minus 5 is 8 over 13 over 2. So this is times 1/2. That's gone. I don't want to go beyond this. Square root of, oh, this cancels. Yay. So that gives me the square root of 4 over the square root of 13. So this gives me 2 over the root of 13, which I can't leave it like that. It's 2 root 13 over 13. And now I'm done. Cosine is going to look similar. It's going to be the square root of 1 plus cosine theta over 2, which is 1 plus 5/13 over 2, and it's the square root of all of that. Guys, just in case you didn't know, I'm in quadrant 1, so everything is positive here. Don't have to worry about the positives and negatives. Want to note that it is positive. It wasn't an accident that I left it off. Okay, so this gives me the square root of 13. Hold on, let's see if I can insert this in an orange or something. 13 over 13, so that's 18 over 13 over 2. So I'm going to put it over 1, keep change, flip it, 1/2. That's gone. 2 goes into 18 9 times. So I'm left with the square root of 9 over the square root of 13. The square root of 9 is 3 over the root of 13, and that would be lovely, but I need to rationalize. And yes, I will dock you a point if you can't rationalize this. 3 root 13 over 13, final answer. And if you're not sure how to do that, come in and see me. We need to work. Last one, tangent, 1 minus cosine theta over sine theta. So that leaves me 1 minus 5 over 13 over 12 over 13. This is one that I need to make it 13 over 13. I had to do that to all of these, didn't I? Had to make them 13 over 13. All right. So this gives me 13 minus 5 is 8 over 13. I'm going to go ahead, keep, change, flip it, or you could have canceled the 13. I keep trying to go back and forth doing them different ways just so you catch it. Now look at this one. I'm going to change the color to cancel it, but see how I have 13 and 13, one on top, one on bottom? Okay, and then now I have an 8 and a 12. 4 will go into each of them. That becomes a 2, that becomes a 3. The answer is 2/3. How nice is that? Still working. Didn't mean to do that. Okay, home. All right, last one, and I've got all the homework done for you. But, sometimes it helps to hear me talking through it instead of just looking at all of it, so I hope this is helpful. On this one, when I'm giving unit circle numbers, I have to remember the first thing I have to do is times 2 in every one of these. So this becomes sine, because I'm using half angle, sine of 150 over 2. Okay, but that's the equivalent to 75. So what I'm going to be doing, sine of 75 is positive, just saying that up front. So I get the cosine of 1 minus cosine, not of 75 because I don't know it. That's what I'm looking for, 150. I have to use the number up there because that represents my theta, over 2. So then I go to my unit circle, cosine of 150, I'm having to do it in my head. That is the square root of 3 over 2, and it's cosine of 150, so it's negative. 1 minus negative square root 3 over 2 over 2. In this one, I'm going to make that plus, and I'm going to make the 1 a 2 over 2. So this gives me a grand total of 2 plus the root of 3 over 2 over 2. This square root is covering all of that, okay? Now, the next thing I'm going to do is put this over 1, so I'm going to multiply by 1 over 2 because I'm going to flip this to remove this. There's nothing I can reduce down. This is going to give you, let's go to another color because it's going to all blend. It's going to go to square root 2 plus root 3 over 4, but that means I have the square root of the top over the square root of the bottom, which gives me, oh, I'm going to run into B. Don't have enough room to write it here. I'll have to rewrite it down below. Let's change colors one more time. Square root 2 plus the root of 3 over 2. Now, this should look like a lot of the stuff we did in class yesterday. All right, almost done. Double this one. Okay, first of all, notice that the square root of 157 puts me in quadrant 2. This answer is going to be negative. All right, negative square root. Just saying, it's going to be negative. All right, so now if I double this, I multiply times 2, I am actually taking cosine. 15 doubled is 30, so there's 300, and 7 doubled is 15. 315 over 2. Okay, 315 over 2. All right, so that gives me, and some of you got to work on your doubling. If you need help with that, guys, I'm really good for it. Okay, 1 plus cosine of 315, which is a positive number, over 2. Cosine of 315 is that 45-degree angle in quadrant 4. So that's the square root of 2 over 2. Got to have a common denominator. Got it. And that's going to give me negative 2 plus the root of 2 all over 2 over 2. I'm going to make it 2 over 1. So times 1/2. This is going to give me the square root of 2 plus the root of 2 all over the root of 4, which is, oh, and it was negative, just lost my negative. Negative 2 plus the root of 2 all over 2. And I'm done. The end. Tangent times 2. Don't forget, 2 times that amount. I love the 2x. That's kind of weird. 2 times 105. I'm getting tired, gang. All right, that's going to be 210 over 2. There's your degree. And so to do this, I need 1 plus, 1 minus. 1 minus cosine 210 over sine of 210. I love these. I don't know why. I think they're wonderful. All right, so this gives me 1 minus cosine of 210. Hold on. I'm just below the 180. I'm doing this in my head. You got to be careful with me. Cosine is the square root of 3, and everything's negative in the third quadrant. So negative root 3 over 2 divided by sine, which is negative 1/2. Look at all of these negatives. Boo. All right, double negative makes a positive. Got to have a 2 over 2. This on the top gives me 2 plus the root of 3 over 2 over negative 1/2. All right, guys, we can cancel that, but don't lose that negative. If you do, you're going to make a mistake. You got to multiply that negative throughout. So on this one, I'm really going to multiply it by Negative 2 over 1. It's gone now because I took it up here. I flipped it to multiply. I'm going to show you this work. Let me grab a green. These will cancel, but this leaves me that negative 1. Okay, don't lose that negative. So now I got to multiply negative 1 times both pieces over here, which is going to give me negative 2 minus the root of 3. And you can't see my negative 2 too well. Final answer, negative 2 minus the root of 3. Okay, done. Have a good one.